Hello, in this video, I'm going to talk about kinematic and kinetic measures of motor performance. So kinematic measures, it's a description of motion without regard to force or mass. Okay, so in kinematics, we're looking at things like flexion, extension, rotation. We're looking at what the actions of the joints and the limbs actually are. We're looking at variables like displacement, velocity, acceleration. So we're describing and analyzing movement in terms of the movement in space and with temporal time considerations, but where we're not doing any calculations or analysis about force or mass. So it's a performance production measure, meaning that it helps us look at how that movement is produced instead of a performance outcome measure where we're simply looking at the final outcome of the movement. So this is a way that we can analyze the way that the movement is taking place and the way that the movement is being produced. Generally speaking, we do that by video recording the movement, and then there are all sorts of methods and ways that we can analyze that video for the kinematics. So there's software, there are applications, we can do it qualitatively, so there are all sorts of different ways. It allows description and analysis of critical components of the skill during the movement. So there may be a specific movement where we watch the video or we watch it live and say, oh, they're dropping their elbow, or they need to have a little bit more arch in their spine, or whatever it is. So we can observe the way that the movement is actually executed and correct those critical components to improve execution of that skill. So that would all be a kinematic analysis. Kinetic analyses involve looking at the forces that are involved in the movement. So forces that are caused by the movement or that cause the movement itself. And so we use all sorts of different methodologies that I'll look at. I'll talk about on the next slide. So again, this is a performance production measure because we're not simply looking at the outcome. This is a way that we can look at how that movement is produced and how it's executed, so that we can make changes as needed to the process, not just to the outcome. All right, so some common ways that we collect kinetic data. Force plates are a big one that helps us learn about ground reaction force and other contact forces depending on how the force plates are used. Very commonly, they're used in gait analysis. So like you'll have force plates that are built into a treadmill or that are on the ground. And then the participant or the person who's being analyzed would walk on those force plates on the treadmill, or maybe you're analyzing squat form or whatever it might be. And so they would do a squat on the force plates. So you can learn a lot about weight distribution and ground reaction forces and things that way. Then there are also force transducers and strain gauges that help measure force produced by a muscle. So depending on how much force the muscle produces and to what extent it shortens, it's going to put a different amount of strain and stress on the tendon. So it's a way to kind of gauge how much force is being produced by the muscle. EMG, electromyography, measures electrical activity in muscles. So there's surface EMG where you put electrodes on the surface of the skin on top of the muscle that you want to measure. And then there's also fine wire EMG where you actually insert the wires right into the muscle. Fine wire EMG is far more accurate. There's a lot less noise, so you're not picking up the signals from neighboring muscles nearly to the extent that you are with surface EMG. But fine wire is also far more invasive. So it's not all participants or athletes or whoever you're working with are going to be interested in fine wire. And so that's a major limitation. So surface EMG is the usual go-to method between the two, but you should always question whether the signal that you're collecting with your surface EMG is from the correct muscle or whether there's noise involved or interference from other muscle activity. Then there's whole muscle mechanomyography. That's another method for detecting muscle activity, but it operates a little bit differently. It's looking at the entire muscle instead of just the local area right where that electrode is placed. And so it has additional benefits compared to EMG, where it actually is able to, well, it's thought to be able to help estimate the muscle fiber composition within the muscle. So the proportion of type 1, type 2A, type 2B fibers within a muscle. Near infrared spectroscopy, sorry. I'm not sure if I'm pronouncing that correctly, but NIRS determines level of oxygenation in the muscle. So it can also penetrate the skull and assess brain activity. It does have limitations in that regard. If you're looking at brain activity, it has to stay very surface on the brain because it's not able to penetrate deeper than that. But it has pretty much the same effect. All right, thank you so much for watching, and I'll see you in the next video.